Welcome, Hornets, and thank you for joining me today. Today we're taking a look at optimization, and we're looking at 5 of the more consistent ways in which we generally have them. So, take a look at what I have in front of you. Starting with the first one, a company has started selling a new type of smartphone at a price of $110 minus 10 cents X, where X is the number of smartphones manufactured per day. The parts for each smartphone cost $40, and the labor and overhead for running the plant cost $4,000 per day. How many smartphones should the company manufacture and sell per day to maximize profit? So our goal is to find the profit formula. So we're going to start off by saying, let's have P of X be our profit. That means that I'm going to have an R of X, which will be my revenue, and then my C of X is cost. Now our profit has to be our revenue minus our cost. Now, we are told that the price of each smartphone is $110 minus 10 cents per smartphone sold. So that means that my R of X has to be $110 minus 10 cents for each smartphone per smartphone. The cost is going to be $40 for the parts per day plus the $4,000. So we have $40 per phone plus $4,000 for the overhead. We're now going to put these together into our formula so that P of X is then going to be 110x minus 0.1x squared, and then we have minus 40x minus 4,000, and let's see, that's going to give me a P of X is negative 0.1x squared, and I'm looking at plus 70x, and I have minus, and let's just see, it looks like that would be 4,000. So now I'm going to take my derivative. P prime of X is now going to give me negative 0.2x plus 70, which I'm going to write as 70 minus 0.2x. Now, this is what I'm trying to set equal to 0. And as I do this, I end up subtracting 70 divided by 0.2, and I get 350 is equal to X. So I now know that I need to sell 350 smartphones per day in order to maximize my profit. And that is my answer to the first question. So let's just go through. We had to start off coming up with a formula for profit. Profit is revenue minus cost. And they tell me the revenue is $110 minus 10 cents per phone for each phone. The cost is $40 for each phone plus $4,000 per day. So we're only talking about one day. We find our formula, we take our derivative, we set it equal to 0, and because it is a quadratic, the maximum or minimum has to be the value we find. Thus, x equaling 350 has to be my maximum. And that is my goal. That is number 1 from this worksheet. Let's take a look at number 2. A cryptographer. You will have seen these before, hopefully. A cryptography expert is deciphering a computer code. To do this, the expert needs to minimize the product of a positive rational number and a negative rational number. Given that the positive number is exactly 5 greater than the negative number, what final product is the expert looking for? Alrighty. So the first thing I want to do is recognize that I'm minimizing a product of two values, an x and a y. I'm going to say x is the positive, in which case it is 5 more than the y value. I now know that my product has to be y times y plus 5, and therefore p is y squared plus 5y. Taking the derivative, p prime, I get 2y plus 5, setting it equal to 0. 2y plus 5 is then equal to negative 5 halves. If y is 5 halves and I plug it back in, x must be a positive 5 halves, and I am looking for the product. So having these two numbers, I have negative 5 halves times positive 5 halves, and the product is negative 25 fourths. That's the product that we are looking for. Once again, let's go through the process. We start by taking what we're looking for. We are trying to maximize product. So product is what I have to ultimately take the derivative of. They then give me a relationship between the positive and negative number. The positive number is 5 more than the negative number. I'm then able to substitute, multiply, take the derivative, and set the derivative equal to 0. Once I have my y, I can then find x, which allows me to find my product. That's what we're trying to do. Let's go to number 3. Now notice that 3 and 4 are almost identical, so just be aware of that. They are very close to each other. A farmer wants to construct a rectangular pig pen using 200 feet of fencing. The pen will be built next to a stone wall, so that only 3 sides of fencing need to be constructed to enclose the pen. What dimension should the farmer use to construct the pen with the largest possible area? Notice number 4 is very similar. What's different is that we are now trying to construct 2 identical pens that share one side. We still have an amount of fencing, and we still have the largest possible area. So let's take a look at number 3 first. So in number 3, we're going to start off by just recognizing if I have a wall on one side and a pen, I have an x, and a y. That means that the 200 feet of fencing has to be made by 2 x's and 1 y, which means that 200 minus 2x is y. We're trying to maximize the area of this, and the area is x times y. Since we know what y equals, we can plug it in, and we have x times 200 minus 2x. I'm now going to simplify it so that area is 200x minus 2x squared. From this, I can now take my derivative. Area prime is 200 minus 4x, setting the derivative equal to 0. 200 minus 4x is going to give me 50. And as a result, I now know that x is equal to 50. If x is 50, then 200 minus 100 gives me y, and y is 100. They are asking, what is the largest possible area? What dimension should the farmer use? So my dimensions are 50 feet by 100 feet, and I would write that in a sentence. Let's compare that with number 4. Making 2 pens that share a side, that are identical. Well, if that's the case, I have an x and an x, x and an x, y, y, and a y. That tells me that the 400 has to equal 4 x's plus 3 y's. And I decided once again to solve for y. So when I solve for y, my y turns out to be 400 minus 4x divided by 3. Now, I'm trying to find the area again, So area is simply x times y. X times y. And I'm going to take my y and I'm going to replace it. Area equals x times 400 minus 4x divided by 3, which is going to give me area equals 400x minus 4x squared, and it's over 3. Now you'll notice this over 3 means that my derivative, a prime, can now be found as 400 over 3 minus 8/3 x. And this is what I'm going to solve for 0. So if it's equal to 0, I have 400/3 equaling 8/3 x. And when I multiply by the reciprocal, I will end up getting 50 for x. 3's cancel, and I have x equal to 50. If x equals 50, I can put that in right here, and I will find that y has to be 200 divided by 3. And this is in feet. Let's see, what dimensions? So my dimensions are 50 feet by 200/3 feet. And I would then put this into a sentence. Now there was only one question left. And I will probably end up having to do that for the class. So please be aware. I will show it to you, but I will not be doing it. If you wish, give it a try yourself. It is simply geometry. We have an engineer designing a box-shaped aquarium with a square bottom and an open top. The aquarium must hold 256 cubic feet of water. What dimension should they use to create an acceptable aquarium with the least amount of glass? That means we want the least amount of surface area. Okay, so please think about this in terms of surface area formulas for a box that has a height and a square base. So that means we got x times x times x times x, or x, 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 and you have y's going along the upper end. Alrighty. Thank you very much, Hornets. I hope this has helped. Please remember, we'll be taking a look at that aquarium engineering box problem in class, and I hope this has helped. If it has, please remember to click like. If not, please remember to give me constructive criticism so that I may improve. Thank you very much, Hornets. I hope all goes well, and please have a very good and safe evening. Good night. Cheers.